All right, lesson 5.5, the law of sines. Yesterday we talked about the fact that if you have a triangle A, B, C, in geometry you learned that the opposite sides from each of these angles, little a, little b, and little c, follow the same proportion as the angles. So in other words, if angle A measures greater than angle B, which is greater than angle C, those less than looks kind of funny, don't they? And put that in parentheses. Then little a is bigger than B, which is bigger than C. With the law of sines, we can actually quantify all of that and write it that the sine of A over little a is going to have the same proportion as the sine of B over side B, and that's also going to be equal to the measure of the sine of C divided by side C. In other words, the opposite side is the ratio of the sine of an angle with its opposite side is going to be the same no matter what angle you take. On every problem we get, you are going to be given 3 pieces of information and asked to solve the triangle, given 3 pieces of information. Today we're going to go through the steps again and then just look at an example problem from yesterday and do a real life application for today. The pieces of information are almost always given. You're either going to be given 2 angles and 1 side, or 1 angle and 2 sides, and from that bit of information you can find the remaining angle or sides that haven't been given to you. In every case, one of the sides will pair up with one of the angles. So in other words, if I give you angle A, I will give you little side A, if that's the angle side combination, and then I might give you angle B, and then you have to find side B from there and the remaining sides. Okay, here are the steps. So you're given either 2 angles and 1 side, or 2 sides and 1 angle. And as we talked about, this is going to be the ambiguous case, and we'll get to that in just a second. If you are given 2 angles and 1 side, the steps for solving. Step number 1, use the law of sines. To find the missing side. So for example, if you're given angle A, you would just say the sine of angle A divided by A equals the sine of angle B divided by little b. And if you don't know B, you would just set up that equation and solve for B. Step number 2, you'll find the third angle by using the 180-degree rule for the sum of the angles of a triangle. So we'll use the 180-degree rule for the sum of the angles of a triangle. Oh, you already know 2 of the angles, so just subtract from 180 and you'll have the third angle. Then step number 3, again use the law of sines. To find the third side. The one exception to this is the ambiguous case. You'll still go through these same 3 steps, but over here you'll consider the possibility that if you were given 2 sides and an angle, that the inverse sine, so you'll get to a step where you'll find the inverse sine to find B. So you'll use the inverse sine. It will give you angle B, but you also have to consider that every inverse sine has 2 possible answers, and you find the other answer by going 180 minus what I'll call the first answer. Then you just repeat steps 2 and 3. So you'll have two sets of answers that will work, and we're going to work a problem, and I'll actually show you what the steps are, or what the triangles look like for that. So the example I want to work, and now even if you're caught up on your notes, try this example to make sure you've got it so you're solid for your quiz, is problem number 20 from the book. They tell you that angle B equals 38 degrees. They tell you that side B equals 21. And they tell you that side C equals 25. So we get something that looks like this. We've got a side C that is 25. We've got an angle B that is 38 degrees. So this is angle B. And we've got a side C, or a side B rather, that is 21. So this is side B. This is angle C, angle A. This is side A and angle C right there. And I'm going to go ahead and pause the recording so that everybody can start to work this problem, and then we'll put the answer up. Okay, I'll go ahead and continue with this problem then, since we've kind of worked through the answers. Again, I went through the 3 steps. I set up the law of sines. I solved for C by taking the inverse sine of this ratio, 25 sine 38 over 21, and I got that angle C has to be 47.1 degrees approximately. And then I went on to step 2, and I took, now that I know 2 angles, the 38 and the 47.1, I subtracted both those from 180 to get that the final angles got to be 94.9 degrees, 0.867. And then finally, I set up the law of sines to find the missing side. Sine of 38 divided by 21 equals sine 94 over C. Solve for C, and you get, I got 33.98, or basically 34. Is that what everyone pretty much got?
So what you did.
Or which step?
Well, I did the second answer for C, which is 180 minus 47. I got 132.
We're not there yet.
Oh, you're not?
No, we're not even touching that case yet. So we'll get to the second case in a second. All I'm doing is I'm going with what the calculator told me the answer was first. The calculator said 47 degrees, because that's one possibility. I'll show you what both the answers, how they work out in a second.
For the next one,
Uh-huh.
the 180 minus 38.
Uh-huh.
Why do we also subtract the answer?
Oh, you have to subtract both angles. The answer was the 47.
Oh, wait, I'm confused.
Yeah, that's from the previous step. There are 3 basic steps to solving a triangle. Use the law of sines to find the missing angle in this case. So I use the inverse sine function. And then I use the 180 rule. Now, there are 2 180 rules, and that may be where people are getting confused. There's the sum of the angles of a triangle 180 rule that says all the angles of a triangle add up to 180. And then there's the inverse sine 180 rule that says the sine of any angle and the sine of 180 minus that angle are equivalent. So when you're doing the inverse sine, you have to subtract your first answer from 180 to consider what the second possibility is.
You get 73.6.
Yep.
So where are you right now? I got 94.
Great. Now, I just found little a by plugging that in, saying what is the sine of 94.8 degrees, 94.9.
Over A, not over C.
Oh, no wonder you're confused. Yes, that should be an A right there. Absolutely. Sorry, that should be a little a. Thanks. Good catch. Now, the second set of answers, and I won't go through them all, is to take 180 minus your first answer. So the second possibility is that angle C could be 47.1 degrees, or I'll call it C prime. A second case, 180 minus 47.1 is 132.9 degrees. Now, if angle C is that, then angle A, when we're going through this 180 minus 38, angle A in this case becomes 180 minus 132.9 minus 38 degrees.
9.3 or 9.13.
Yeah. So it's about 9.1 degrees. Mhm.
is like,
Oh, I'm sorry. It should be a capital A. I'm talking about angle A. Talking about angle A is 9.1 degrees. Angle C is 132.9. Over here, you said A was, what, 94.9. Look, angle B in both cases is 38 degrees. That's not changing. So let's just talk angles for a second. Angle B is 38 degrees because they gave you that. Angle C we calculate from the law of sines using the inverse sine function. One possibility is it's 47.1. A second possibility is when you subtract from 180, angle C could also be 132.9. The sine of both of these numbers is exactly the same. Well, of course, triangles add up to 180 degrees, so if you change C, you've got to change A, because these three numbers always have to add up to 180 degrees. So when C prime, you said it's 132.9, angle A has to be 9.1.
I got 10.
Okay.
Got
It,
rounded.
yeah, you rounded. It's fine. Okay. You know what might help? Let me show you what the two triangles actually physically look like.
So you said
Mhm.
they equal the same thing, so from what they gave us, like, it could be either of these triangles.
Precisely. That's exactly the point. Lisa brought it down to something that makes sense. It just means it could be either one. Let me show you what the two triangles actually look like. Right. Angle B is 38 degrees. Side C is 25. So in both cases, this is a side. Whoa, I didn't mean to move it. Oh, well, it's not going to write unless I use the pen. In both cases, I have a side that goes up here, and I meant this to be 25 centimeters. It just got adjusted when I moved it around just now. So in both cases, it's 25. In one case, angle A up at the very top is a 94-degree angle, and it comes down at 21 and comes back over, and side A is 33.9. Something like that. We calculated 34, I think. In the other case, you could have a B that slants in at 21 this way. And let me undo this so that it's actually back to where it should be. It slants in, and we also have, it still fits the rules. Side B is 21, side C is 25, and the angle is exactly 38 degrees. It's just now the side A prime, is much smaller. Notice how little angle A is in that case. The two triangles are, by the way, the skinny little triangle and the very big triangle. Yep. All right. I'm going to work a practical example in class, but I think that's enough for the recording bit.